Applications of these two laws. The current distribution in various branches of a circuit can easily be found out by applying Kirchoff's current law at the different nodes or junction points in the circuit. After that, Kirchoff's law is applied in each possible loop in the circuit and generates algebraic equation for every loop. By solving all these equations, one can easily find out different unknown currents, voltages, and resistance in the circuit. So it would be helpful in electrical engineering while designing circuits. Here we can see the examples of applications of those two laws. At this node junction in an electric circuit, the sum of currents flowing into the node, in this case it is the 8 ampere current, is equal to the sum of the currents flowing out of that node. So 8 equals the sum of the 3 and 5 amperes currents. This animation shows a multiple loop circuit which illustrates Kirchoff's second law, which states that the sum of potential differences as you go around the loop is equal to 0. You can see the smaller two loops and the sum is 0. And on the bigger loop, it's exactly the same. The sum is always equal to 0. In real world application is for monitoring, for example, for monitoring and optimization of power grids, where the engineers in real life monitor, in real time they monitor the current flow in the power lines and adjust it based on their needs. Also, we can find out the application in electronics and in many different situations. Thank you for watching this video and goodbye.